Lesson 44, solving right triangles. In this lesson, we're going to be looking at not only solving for different sides or different sections of triangles, but we're also going to be looking for solving for missing angles of a triangle. We're just going to start off by doing some examples and walking you through these, and hopefully after we do a couple examples, you'll get the hang of it and start to be able to do some on your own. In this triangle, we are solving for y, h, and b. Y and H are both sides of our triangle. B is an angle. Always look, the very first thing you want to do is look for your angles first. Obviously, we're working with a right triangle, and a right angle is always 90 degrees. Our opposite angle is 24 degrees. So, based on our rules about triangles, we know that 180 degrees total is in a triangle. If this angle here is 90 and this angle is 24, we can add those together and then take that sum from 180 to find the difference, which will be angle B. So if we add 90 and 24, we get 114. And if we do 180 minus 114, we get 66 degrees. So B is equal to 66 degrees. Now what we want to do is find our missing sides, Y and H. In order to find missing sides of a right triangle, if you are missing more than one side, you want to use your sine, cosine, and tangent function. So what we're going to do is we are going to use sine, cosine, and tangent to find y and h. You can either pick to base it off of the 24-degree angle, or you can base it off of the 66-degree angle. For this one, I'm going to choose our 24-degree angle, and I'm going to base all calculations off of that. So I want to look at 24. If we're looking at basing everything off of this 24-degree angle, we know that y is opposite, and we know that h is the hypotenuse. So we're going to have to use our trig functions that involve the opposites and also one that involves the hypotenuse. But we also have to determine what side we know. We know the adjacent side. So we're going to use the angle that we know and the side that we know in order to find the sides that we don't. If I'm solving for the opposites and I know the adjacent, we've got to figure out which trig function goes with opposites and adjacent. That, of course, is tangent. So we're going to say that the tangent of 24 degrees, because that's the angle we're basing it off of, is equal to the opposite over the hypotenuse. Well, the opposite of 24 is y. I'm sorry, opposite over adjacent. The opposite is y, and the adjacent is 9.5. So now we have this equation. Tangent of 24 equals y over 9.5. We're going to solve this like a proportion, and we're going to cross multiply. So in your calculator, you would type in 9.5 tangent 24, and whatever we get is going to be equal to side y. So if you type into your calculator 9.5 times the tangent of 24, you should get that y is equal to 4.23, and that's the length of segment y. We're going to use something similar to solve for side h. Now we said that side h was the hypotenuse, and we know the adjacent side, so we're going to use a function that deals with the adjacent and the hypotenuse, and that, of course, would be cosine. So we're going to say the cosine of 24, because we're still basing it off of that 24-degree angle, is equal to the adjacent, which is 9.5, over the hypotenuse, which is h. Again, we're going to solve this like a proportion. So we're going to cross multiply. H times the cosine of 24 is going to be equal to 9.5. And just like we would in solving for a variable, we're going to divide by the cosine of 24 on both sides to solve for h. If you were to type in your calculator 9.5 divided by cosine of 24, you should get that h is equal to 10.4. Let's try a second example. In this example, we're solving for x, m, and b. Just like we did previously in the last one, we want to look to see about our missing angle first. So we're going to look at our angle B. It's the only angle that we do not know. We know that this angle here is 35, this one is 90, and all three have to add to equal 180. Well, 90 and 35 together is 125. So we do 180 minus 125, and B is going to be equal to 55 degrees. Okay. we're going to use our trig functions, sine, cosine, tangent, to solve for m and for x. Again, I'm going to base mine off of this 35-degree angle. Side m is adjacent, and side x is opposite. So I want to use a function that deals with opposite and adjacent, but I also have to keep in mind that the only side I know is the hypotenuse. So I'm going to start off with finding x. X is opposite, and I know the hypotenuse. So the function that goes with opposite and hypotenuse is sine. So I'm going to say the sine of 35 is equal to the opposite, which is x, over the hypotenuse, which is 14. We solve these by cross multiplication. So 14 times the sine of 35 is going to be equal to x. If we type this into our calculator correctly, we should get that x is equal to 8.03. We also want to solve for m. M is adjacent to that 35-degree angle, and again, we know the hypotenuse side, so we're going to use the function that's adjacent over hypotenuse, which is cosine. So the cosine of 35 is the adjacent, which is m, over the hypotenuse, which is 14. So in order to solve for m, we're going to cross multiply 14 times the cosine of 35, and that should give me side m. And if we type that into our calculator, we should find that m is equal to 11.47. All right, in this triangle, we're solving for h and y. I'm going to have you do this one on your own. I'm going to help you with just a couple steps. Notice that we're not having to solve for this angle because you can base everything off of this 21-degree angle, so you don't necessarily need the opposite angle unless it asks for it. Keep in mind that the side you know is the adjacent and that you're looking for the opposite and the hypotenuse, so make sure that you use the correct functions accordingly. If you need to hit pause on the video to copy this down, go ahead and hit pause. Hit play when you're ready for the next example. The next example is in this triangle here, and we're solving for p, x, and y. Notice that in any time that you want to find the measures of an angle, you use the inverse function. I'm going to go ahead and walk you through finding at least one of these angles. Also notice that you know two sides of the right triangle and you're only missing one side. And when you're missing one side of a right triangle, what do you use to find that missing side? So keep that in mind as you're solving for p. Now, if we're going to solve, we're going to go ahead and I'll solve for y with you, and then I'll have you do x on your own. If we're solving for y, I want to know what sides I know. I know the adjacent side and I know the opposite side. So what function goes with adjacent and opposite? And that's tangent. So I'm finding the tangent of y. Now, I don't know what y is, but I do know that the tangent of y is the opposite over the adjacent. The opposite is 12, and the adjacent is 8. If I'm trying to find the tangent of y, I'm going to go ahead and do 12 divided by 8, which is 1.5. In order to find out what the angle is, remember anytime we're solving for an angle measurement, we do the inverse function. So I'm going to do inverse tangent of 1.5. 1.5, and that will give me angle y. So if I type in my calculator inverse tangent of 1.5, I should get that y is equal to 56.3 degrees, or 56 degrees. And that gives me my angle measure. Go ahead and try the same thing for x, and we will check when we come into class.